Hello guys, and welcome to the new video on Microbit Pomodoro project. What we built so far is a fully functional Pomodoro timer that counts for 25 and 5 minutes alternatively. At the end of each phase, we are displaying the string of the new phase that is starting up. What we would like to do next is to improve on this by providing some visual and audio alerts so that user can be informed better once the timer reaches the end of the phase. So we would like to flash all LEDs on and off few times. That would be our visual alert. And for the audio alert, we would like to play some notification sound. Before we do any of that, let's switch back to our finite state machine diagram to see how we can fit this new state into our finite state machine. Let's continue from where we left off last time. We have a simple finite state machine with only 3 states and with transitions between them by pressing on button A to go from minute to running, from running to pause with press on button A, and back from pause to running again with press on button A. And we can go from pause to init by shaking the Microbit board. There is one flaw in this design, and let's try to understand what's happening by inspecting the code. This pause block will take significant amount of time while we are in the running phase. So what I want to say is that this change timer by -1, calling this display LEDs and evaluating this if condition will take very little time out of this 1 second slot that we have for each tick of our Microbit board. So while we are executing the pause block, let's say that we are on this executing this block, meaning that Pomodoro timer is waiting, and we press on button A. So we are transitioning from running state to pause state. Even though that the state has been changed from running to paused, we are still inside this if block because we went in. Pomodoro will continue to evaluate other blocks. So it will go and execute this change block. So it will lower the timer by 1. It will call display LEDs and it will evaluate this condition if timer is equal to 0. In the worst case, it will go in here and it will call one of these save display string functions. But let's say that we don't have such a scenario, so we are coming back to this if condition. If state is state running, it is not, and then it will not execute any of this code. But let's try to rearrange this a little bit so it works differently. If we go and change our running state to delay state and introduce another state that is called tick, we can basically separate the pause block from the other blocks that are called in running state. And they will go from one to the other. So once the delay is finished, then it will go to tick function to tick state that will actually execute those display LEDs and evaluate the if condition, and after that it will go back to delay state. One important thing is that from delay state to tick state we should switch only if the state itself is still delay at the end of the period. And let's see what does it mean. If we are on this pause block and then we go to this if condition, we are checking if state changed. So if the state is no longer state delay, it will not go to this tick state. And this is exactly what we wanted to do to prevent our timer going down by 1. Now we can also introduce another state that is called timer finish, and we can go from tick to timer finish, and after timer finish finishes, then we can go back to delay state. The important thing to know is when we are going from tick to delay and from tick to timer finish. Only if timer is still greater than 0, we are going back to delay, and if timer is equal to 0, we are going to timer finish state. Now let's see how it looks. This is the code that we had before, or we currently have, and we want to transform it to this code. So we are separating our pause block. You can see that it is only present if state is equal to state delay. And after this pause block, if state is still equal to state delay, then we can go to state tick. And in our state tick, we are doing what we did before. So we are changing timer by -1. We are calling display LEDs. And then we evaluate if timer reached 0 or not. If timer reaches 0, then we go to new state, timer finish. Otherwise, we go back to state delay. And this is exactly in line with what we have in our new diagram for the finite state machine. Now we can switch back to code and try to implement this new finite state machine. Let's start with dealing with the states. So we have 3 states and we want to change them to the 5 new states. We can take the state running that we had before and we can simply rename it to state delay. Next, we need to introduce new state, state tick, and another one, state timer finish. We want to set them, so I can drop one block here. I can copy one block over here. Let me zoom in a little bit. And let's say state, so we have state init, state delay, state tick, state timer finish, and pause. We can go 0, 1, 2, 3, and 4. Next thing that we are going to do is to split our forever block that we had from before. And it is this one. You see how it is already, this state is renamed from state running to state delay, and we need to split this into other blocks. But let me check first. Let's move this pause block above. I will rearrange all of this later on, but for now I want to have another forever block. So let's search for forever. And we can say we need if condition. Let's just grab this one. If state is equal to state delay. In this case, we want to do pause. I will just copy this over and then I will clean it later. So now after we have our pause, we want to go back to tick state, but first we need to inspect if the current state is still state delay. So we are just copying this block. Oops. Let's try this again. And if it is, then we are going to set we need to set the state to state tick. The next change is going to be introducing another forever block, and let's grab another one. And this one will represent our tick state. Let's copy all of this and simply edit. So if state is state, not timer finish, but state tick, what we want to do. In our ticking state, we don't need pause block, and we can simply delete it. Let's take all of this and break it apart. So we want to change our timer by -1. We want to call display LEDs. And we want to inspect if timer reached 0 or not. So let's just take this if block back into here. If timer reached 0, we want to set timer to, we want to set state to timer finish. Otherwise, we want to go back to state delay. Last thing that is left to do is to check what we are going to do with our state timer finish. So if the state is equal to state timer finish, then we are simply going to use all of this that we had before, where we are checking what is the new phase, if it is the work phase or not. So we are displaying the work and break strings. And this is the preparation for what we are going to do in the next video, and that is to provide this visual and audio alerts, but at least we have a good structure. Now let me just arrange a little bit of our blocks so that it will look nicer. Okay, so this is what I wanted to achieve. We have all our utility functions on the top. Then we are following with our input. So we have on start, we have button A, button B, and on shake with their corresponding functions. Then we have forever blocks with our states. So this is the one for the state pause, then one for the state delay, and then we have state tick. Since it has this display LEDs function, it is put next to it, as well as the plot LEDs and the should plot function, and at the end we have the one for the timer finish. This is all for this video. Thank you for watching. I hope that you enjoyed this, and see you in the next one. Bye bye.